Let's look at the Euler's number in this video. The Euler's number is defined. It has two definitions. The first one, if you have E, this E is what we use to represent the Euler's number. It has two definitions in terms of limit of function. So we have the limit as n tends to infinity of 1 plus 1 over n all raised to power n. Now look at this. This is what we call what? The Euler's number. You can see in terms of limit of function, we use this to evaluate limits a lot. And I'll give us several examples in this video. So just take note. If you have limit as n tends to infinity, 1 plus 1 over n raised to power n, this is called the what? The Euler's number. Also, if you have E, this E is also equal to the limit as n tends to 0, 1 plus n all raised to power 1 over n. You can see, observe the pattern we have here. So take note of it. Take note, very, very important. And have something in mind that if I have, you see the number here correspond to the raised to power 1 that you have here. Let me assume that I have limit as n tends to infinity of 1 plus, let me say, k over n all raised to power n. This is the same thing as e to the power of k. Please have this in mind also. It's very, very important. So since we know all this identity, let's go ahead to solve some practice problem. So question 1 goes thus. How do we solve this? If you have limits as n tends to infinity of 1 plus 1 over x all raised to power 4x. Looking at this question, you will know that this has infinity, this has infinity. And you can see that they have the same pattern. Good. Another thing you need to take note of is that you see the number you have here, n, correspond to this n you have here. Whatever you have here must be equal to what you have here. Now check it out. What I'm having here is x, what I'm having here is 4x. Find a way to write it in a way that x will only be here. So I can rewrite this as the limit as n tends to what? Infinity of 1 plus 1 over x, then all raised to power x, then this will be raised to power 4. Observe, this can also multiply this to give me 4x. So I've actually not changed anything. Now, by the Euler's number, you can see this one will be equal to what? E to the power of x. You can see, sorry, will be equal to e. Because what I'm having here is exactly the same thing as what I'm having here. Then I have my 4 raised to power 4. So the value for this is what? E raised to power 4. Let's look at another problem. If I have the limit as n tends to infinity of 1 plus 1 over x, 1 plus 1 over x, then all raised to power x plus 5. How do we evaluate this question? Okay, you observe that this one is taking this pattern, but the thing is that I'm having x here, but here is x plus 5. So how do we go about this? Did you know that I can still rewrite this as the limit as n tends to infinity of 1 plus 1 over x raised to power what? Raised to power x, then multiplied by 1 plus 1 over x raised to power 5. Can we still remember this certain law called law of indices? Remember that if I'm having a raised to power m times a raised to power n, it is now a raised to power n plus n. So this one can be reversed from here to here and from here to here. Now check it out. I'm having addition here, so I can write it as multiplication. So this is very possible. So since they're having the same base, we can pick one and add the powers together. Now, since we have this, so what do? We know that this is just the what? The Euler's number. And take note of something, that I can separate this limit for both of them. So I can have, let me erase this. I can have the limit as n tends to infinity of 1 plus 1 over x raised to power x times the limit as n tends to infinity of 1 plus 1 over x then raised to power 5. Remember, this is the Euler's number, so I have e. Then multiply by, look at this one. I can't apply Euler's number here because what I'm having here is even 5. What I'm having here is x, entirely different from each other. So what do we do here? Take note that if I apply these limits here, you remember, what is the limit as n tends to, sorry, what am I having? This should be x. Limit as x, this is x, this is x. So this is x, this is x, this is x. Limit as x tends to infinity of 1 over x. Remember, as this one goes to infinity, the whole fraction goes towards 0. So what I'm having here is actually what? 0. So I'll be having 1 plus 0 raised to power 5. So this is 1 raised to power 5, and our answer here is what? Is E. Okay, that's that for that. So let me erase everything and try to jot it down. So let's look at another problem. If I have a question like this, okay, let's see this pattern of question. Limit as x tends to 0, x times 1 minus x squared all raised to power 1 over 2x squared, then all over sine x. Now, see, when you are trying, one of the way you actually know how to solve problem correctly is for you to know how to observe. You observe that I already know this identity from our previous video. You see the link in the description box below. This identity, x over sine x, we actually know this one is equals to 1. So you can see that pattern here. Good. Another thing again is that we've also learned that the limit as x tends to 0, 1 plus x goes to power 1 all over x is equal to e, which is the Euler's number. And you can see that you can actually observe the pattern here. So let's go and solve intelligently. So I have limit as x tends to 0 of x over sine x times limit as x tends to 0 of what? 1 minus x squared, then 1 all over 2x squared. Now, you see that I want to use this pattern. So, observe the way I'm going to do this. Remember that this one is equals to 1. This one here is actually equal to 1. So, I'll be left with this only fraction here. So, I'll be having the limit as x tends to 0 of, check it out, 1 plus minus x squared, then raised to power 1 over x squared, then all raised to power, what? 1 over 2. You observe that I can still go back to what I'm having. So my steppings are legit. Also, I can write this as 1 plus negative x squared. Check this out. Remember that what I'm having here must exactly, what I'm having here must exactly correspond to what I'm having here. This is x squared, and this is negative x squared, and this is x squared. So what can I do? See, I can just do something like this. Observe. Negative 1 over x squared. So I'm having negative x squared. Then I'll come here and put another what? Another negative. Another negative 1 over 2. So you observe that if I multiply out like this, it will still give me what I'm having here. Good. And remember, this is the Euler's number. You can see 1 plus n raised to power 1 over n. It's still the same thing. So therefore, this is the Euler's number. So I have what? And that will be equal to E, then negative 1 over 2. So this is my final answer. So as required. So let us solve one challenging problem. You can pause the video to give the problem a trial. So let's see what you've got. Let's see. If you have a question like this, the limit as x tends to 1 of x to the power of 1 over x minus 1. Okay, so let's see. How can we solve this question? You observe that it doesn't seem to obey any of the identity I've given us. But one of the ways we can do this is by substitution. I can say let me write in our color. I can say let what? Let n be equal to what? X minus 1. And if you observe, if my n is equal to n minus 1, that implies that x should be equal to what? N plus 1. Now, this is what I have. You observe that, check here. You also substitute this point as x tends to 1. So looking at what I'm having here, I'm having C. As x tends to 1, what happens? If x tends to 1, you see that what? N will tend to what? N will tend to 0. As x tends to 1, n tends to what? N tends to 0. Now, that's what I have. Because if I put 1 here, 1 minus 1 will be 0. Good. So let me now replace it back with what I have. So I have limits as x tends to, no, I'm not using x again, I'm using n. So as n tends to 0, what is x now? X is the same thing as what? N plus 1 or 1 plus n, then 1 all over. What's x minus 1? X minus 1 is what? N, 1 over n. Now, did you see how we are solving this? So by definition, what happened? What is there? Limit as n tends to 0, 1 plus n raised to power. This we call to what? E. And that's the final answer. So it's very, very simple. So let us explore more challenging problem. How do we solve this? If I have the limit as x tends to 0 of x root of 7x plus 1, how do we solve this? Okay, let's go. Looking at this, let us just rewrite this like this. X tends to 0. This one, remember, if I have square roots of, let me say, nth roots of a certain number, this is the same thing as 1 over n. So I will write this as 7x plus 1, then 1 over x. Now, it's getting easy from here. So what do you think I'll do? I'll just write, okay? I'll write what I'm having here like this. The limit as x tends to 0 of, I can write it as 1 plus 7x, then raised to power 1 over 7x times 7. So what I'm having here is 1 over 7x times 7. Because if I divide this out, I'll still have what I'm having. And you observe what I'm having here is same as what I'm having here. And it follows this identity. Limit as n tends to 0, 1 plus n raised to power 1 over n, which is e. So since we know this, so our final answer there is equals to what? E to the power of 7. And that's our final answer. Okay, let's look at some challenging problem also. So let's look at more challenging problem. Okay, let's see. If we have, okay, let's see if we have, let's see if we have this. If you have the limit as x tends to e of ln x minus 1 all over x minus e. Let's see how we can solve this using the Euler's identity. Let's see. Now, looking at this, you observe that I can make substitution. Once you see that what you're having here is not tending to 0 or infinity, try to make some substitution. And one of my substitution, observe, I can say let y be equal to x minus e. Okay, so it means that from here I can say my x will be equal to y plus e. So this is what I have. Now you observe that next change your limit. As x tends to e, what happened? My y will tend to what? 0. You observe e minus e is what? Is 0. Now from here, so what I'm having here, will now be equal to the limit as y tends to 0. I've changed my limit from x to y now. Then what happened? I have what? Ln x. And instead of me to write x, I'll write y plus e. Ln y plus e, then minus, what am I having here? 1. Okay, let me write my 1. All over x is what? X is y plus e, then minus e. So what am I having here? This is the same thing as limit as y tends to what? As y tends to 0 of ln y plus e minus, what is 1? 1 is ln e. Did you know that? Punch ln e in your calculator, you have what? 1. Then all over y. So from here, what do you think I will do? So I can rewrite this as the limit as y tends to 0. This ln is a logarithm. So if I combine the logarithm together, I'll be having, firstly, I'll write this y as 1 over y. Then this one is ln y plus e over e. Did you see that? Ln y plus e over what? Over e. So remember, I can rewrite this as 1 over y ln this same thing as what? 1 plus y over e. Do you see that? Because if I separate this for both of them, I'll be having y plus 1 plus y over e. Okay, let's see. Did you know that this is a logarithm? So it's possible for me to bring this 1 over y up here. It's very, very possible. 1 over y up here is very, very possible. So what do you think I will do? So I can say limit y tends to 0 ln 1 plus y over e all raised to power 1 over y. It's very possible because check it out. In law of logarithm, let me remind us. Let me say I have log. This ln is also log. Let me say I have log k m and I have n. This n can always travel at the top, and that's why this y can also travel at the top. Nice. Now, since we know this, what happened? We proceed. Now, the thing is that we need a task. And what was the task? Okay. Find a way to express this as, remember, this is modeling this identity, which is the limit as n tends to 0, 1 plus n all raised to power 1 all over n. Can you try this out? Which is e. How can we make this equal this? Okay, from here, what do you think we are going to do? Observe. Firstly, let's make this and this the same. So I can write this as limit as y tends to 0 of ln. What I'm having here is this. 1 plus 1 over e over y. Do you see that? Do you see that e over y is same as of y over e? Okay. Now, how do we make this power as e over y? So let's see. If I write this as e over y, surely I must make sure that, I multiply the top by e so as for it to be e over y. Similarly, I must also divide by that same e so I can return back to what I have here. So, take note of something. What I have here, limit as y tends to 0, is e over ey. Now, see something. I can write e over ey as 1 over e times e over y. So this 1 over e here, I can write it as limit 1 plus 1 over e over y. Then I have 1 over e times e over y. Alright, that's what I have. So let's see. This 1 over e can come down here just as a logarithm. So I can have limit as y tends to 0 or 1 over e ln 1 plus 1 over e over y, then raised to power e over y. So this one, I can write this as the limits as y tends to 0. This 1 over e is a constant, so I can put it out, 1 over e. Then I'm having ln 1 plus 1 over e over y raised to power e over y. This limit can penetrate inside this logarithm, so I'll be having 1 over e of ln of the limit as y tends to 0, 1 plus 1 over e over y raised to power e over y. So this is what I have, and check it out. This is our normal law, which is equal to what? E. So I have 1 all over e ln e over y. So looking at what I'm having here, no, ln e only, please, ln e. So looking at what I'm having here, what is ln e? Ln e is equal to what? It's equal to 1. So I have 1 over e times 1, and my answer is what? 1 over e. Or you see your answer as e raised to power minus 1. So that is how to solve the question. And that is it. So if you truly understand this, and you can actually show by commenting on this problem. So solve this task. Solve this task. Solve this. If I have the limit as x tends to 0 of 1 plus sine x raised to power 1 all over x. How do we solve this? So comment your answer below, and thanks for watching.